There are a few different methods to sizing ductwork in Revit. You can simply change the size of each duct segment as you sketch ducts, or you can size the ductwork after it has been created. In this model, there are 3 duct systems that already have ductwork laid out. However, the ductwork has not been sized. In this example, we will size one system manually and then have Revit size the system automatically. Then we can compare the differences. I'll zoom into the southeast portion of the building to the system being served by water source heat pump 2-1. As you can see, there is one main vertical duct and one main horizontal duct. The horizontal duct is one segment, but I know that it will need to reduce in size along its length. So we can simply split the element where we want a size change. I'll switch to the Modify ribbon. In the Modify panel, I'll select Split Element. With the Split Element tool, you simply click on an element in the location where you want the element to be split. So I'll click on the horizontal duct to the right of the first 2 taps, and then again to the right of the second 2 taps. Then I'll click Modify to end the command. Now we have 3 portions of the duct that we need to size. Different designers have different preferences, but you may wish to create working views in which you place tags with certain information to help design, and plotting views with tags that you need for documentation. For example, when sizing ductwork, it is useful to have the airflow of each air terminal readily available. You may have a table listing the airflow for each system or each space. You could also place a tag on each air terminal listing its airflow. In this case, I can select each air terminal to see its airflow. The 2 air terminals on the right total 560 CFM, or 260 liters per second in the metric file. There are also a few methods to sizing ductwork in general, such as by friction, velocity, or static regain. In this example, I'll use a friction method at 0.08 inches of water gauge per 100 feet for imperial units, and 0.65 pascals per meter for metric units. I'll also leave the duct height constant at 12 inches, or 300 millimeters in the metric file. So first, I'll select all the main ducts by using the Tab key to highlight the chain, and then I'll click to select them. In the options bar, I'll change the height to 12 inches or 300 millimeters in the metric file. Then I'll select just the duct on the right. Looking at a ductilator, it appears that the width for a duct with 560 CFM or 260 liters per second should be 10 inches or 250 millimeters based on the friction and height we discussed. In the options bar, I'll change the width accordingly. Now I'll select the center horizontal duct. The total airflow in this duct is 1,110 CFM, or 516 liters per second in the metric file. Back to the ductilator, it appears that the width for this duct should be 16 inches, or 400 millimeters in the metric file. So once again, I'll change the width in the options bar. Lastly, I'll select the left horizontal duct, the elbow, and the vertical duct. The total airflow in the system is 1,660 CFM, or 772 liters per second in the metric file. Looking at the ductilator again, it appears that the width for these duct segments should be 22 inches, or 550 millimeters in the metric file. So I'll change the width in the options bar. Now this system has been sized appropriately. However, I want to use the duct sizing tool in Revit to compare the results. So I'll click Undo in the Quick Access toolbar until the duct sizes are back to the original sizes. Be careful not to undo the splits in the duct though. When using the duct sizing tool, you will still need to split the duct where you want size changes. With the ductwork all at the same size again, I'll move my cursor over a duct, press Tab to highlight the main ductwork, and then click to select the ducts. The ribbon actually changes to a multi-select contextual ribbon, and there are several options. I'll expand the Analysis panel and choose Duct Pipe Sizing. Revit displays the duct sizing dialog since I have duct selected. You can use the tools in this dialog to choose how you want Revit to size the duct. Also, realize that Revit will use the sizes available in the mechanical settings to size the duct. So if there are certain sizes that you do not want to use when sizing duct, you will want to turn those off. For example, you may not use odd number sizes. There are actually two sections in this dialog: Sizing Method and Constraints. Under Sizing Method, you can expand the drop-down and select the method you want to use. The available options are friction, velocity, equal friction, and static regain. I will choose friction. Then in the field next to it, I'll set the friction to 0.08 inches of water gauge per 100 feet, or 0.65 pascals per meter in the metric file. If you choose the friction or velocity methods, the radio buttons below the sizing method drop-down are available. For example, with friction selected, you can choose AND to use both the friction and velocity methods when sizing the ductwork. You could also select OR to use both methods. However, with OR selected, the size of the duct is allowed to break either the friction or velocity rule, but must comply with one. I'll leave it set to Only. If you choose equal friction or static regain, these radio buttons will not be available. In the Constraints section, you can expand the branch sizing drop-down and choose Calculated Size Only, Match Connector Size, or Larger of Connector and Calculated. Since I did not select any branch ducts, this option will be ignored. But be aware that they are available when sizing ductwork. Below that, you can choose to restrict height or restrict width. Since we sized the duct previously based on a height of 12 inches or 300 millimeters in the metric file, I'll select Restrict Height and choose 12 inches or 300 millimeters in the list. With all the options selected, I will click OK to let Revit size the ductwork. Once Revit has calculated the duct sizes, I can select each duct segment and we can compare the size to our previous results. As you can see, the sizes that Revit came up with match the sizes that I came up with using a ductilator.